for question 1, we have a rectangle. So imagine our axes are like this, and we want to get the area of the rectangle, which is, say, something like this. So this is 0, and we know the length is 3, so that'd be 1, 2, 3, and the height of it is 2, so this would be 1, this would be 2. Now we just apply the trapezoidal rule. So the area is the width over 2 times the 2 endpoints plus twice the other ones. We'll do this in slightly greater detail now. So first of all, we need to work out what the width is. Well, the length here is 3, because it goes from 0 to 3, and we're breaking it into 3 intervals, from 0 to 1, 1 to 2, 2 to 3. So that means the width is equal to 1. What about h1, h2, h3, h4? Well, they're just going to be the height of the function. So in this case, whatever it is at 0, whatever it is at 1, whatever it's equal to at 2 and 4. So these are h1, h2, h3, h4. But since it's a rectangle, it's a constant. So they're all going to equal 2. So h1 is equal to h2 is equal to h3 is equal to h4, which is equal to 2. So now we just plug those into the formula. So the area is equal to the width, which we know is equal to 1, over 2 times h1 plus h4. These are all equal to 2, plus 2 times the other 2 widths, and there we have it. So now we just work that out. A half times 2 plus 2, which is 4, plus 2 times 4, so that's equal to 8. Add those up, we get 12. Divide by 2, we get 6. So that's equal to 6. So that's what we get applying the trapezoidal rule. What about using our formulas? Well, for a rectangle, area is equal to width times height, which is, in this case, 3 times 2, which is also equal to 6. So in the case of a rectangle, we get exactly the correct answer. Next, we want to look at the circle and see what happens there. So in question 2, we want to find the area of a circle. So I'll write that down here. Circle, radius 3. So what I'm going to do is, plot it and see what we get. This is actually a harder question than I meant it to be. I mean, it will be a tricky one if they actually ask you this. So what I did was, so say we draw the circle. So, okay, not the best of circles, but you get the idea. So this is radius 3. So I'll say that's 0, 1, 2, 3, 4, 5, 6, or -1, -2, -3. What I'm going to do is work out the area of the top part, because the trapezoidal rule assumes that if you, well, it assumes that it's full from the bottom. So if I was to say use that as my base for the trapezoidal rule, it wouldn't know that I mean to only count the part that's inside the circle, ignore this part, the dotted part, which is not part of the circle, because all we're telling the trapezoidal rule is a couple of points. We're saying it's this high at this point, it's this high at this point. It just wouldn't know what to do with it. So the way we can deal with it is just look at the top half and count the part that I've marked here. So we're only taking the area of the top half, which is why it's a bit complex as an example question, but it's otherwise the same. The other difficulty here is that we haven't done the circle yet. So the trick, the way I do it, kind of assumes the idea that you have, but you'll see that it's the basic process is the same. So look at the top half circle and just apply the formula. So I'm going to break the top half, break top half into 3 intervals. So x1 is going to be -3. Where'd it go? So that is going to be x1. That's going to be x2. No, I'll actually break it into 4 intervals. So x1 is -3. x2 is going to be that's x4 and that's x5. So x1 is -3, x4 is equal to 1.5, x5 is equal to 3. So again, here's the circle. It's radius 3, so it goes from -3 to +3, and we've just picked these 5 points. Again, you could have picked other ones. The next step is to work out h1, h2, h3, h4 and h5, because I need to know, I mean, for the formula I need the width of the intervals and I need the heights. So that's the part that if you'd done the circle, it'd be easier to do. So I'll just do a quick bit on that. The circle uses the fact that x squared plus y squared is equal to the radius squared. So what that lets us do is say that y squared, and the radius here is equal to 3, so it'll be y squared will equal to 9 minus x squared, and that means that y is equal to the square root of 9 minus x squared. That, you don't need to know that to do the trapezoidal rule. So this question is unnecessarily complex. But you will do this when you do the circle. But all we need to do is just apply that. So we need to know h1, h2, h3, h4, and h5. These heights. So if this is x1, the value of y1, or if this is x2, the height of this when x is equal to x2 is equal to y2, and we know that that's equal to x2 squared minus 9, the square root of, using this. So we just plug that in to our expressions. Well, h1 we know is equal to 0, and we know h5 is equal to 0. That just from the picture. So h2 is going to be the square root of 9 minus 1.5 squared, because the middle part has x is equal to 0, and x1 and x5 have x is equal to minus 3 and x is equal to plus 3. And that's why h1 is equal to 0. I mean, you just plug it into 9 minus x squared. When x is equal to minus 3, that gives you 9 minus 9 is equal to 0. Where for x3, we have x is equal to 0. So we end up with the square root of 9 minus 0. So that's going to equal 3, which it should be, because when x is equal to 0, that's when the height of the circle is equal to the radius. That's the maximum. This is, again, 9 minus 1.5 squared. So now we just work out what 9 minus 1.5 squared is, and then take its square root. So that comes out at 2.6, and that comes out at 2.6. So once we know what h1 to h5 is, we just plug it into our expression for the trapezoidal rule. So the width is equal to 6, twice, like 2 radiuses, divided by 4, because we've broken into 4 intervals, one for like x1 to x2, x2 to x3, and so on. We divide the width by 2 in the formula. We multiply it by h1, or we multiply by h1 plus h5, and so h1 plus h5 plus twice the other ones. So twice 2.6 plus 2.6 plus 3, and there you have it. I mean, that's the area of the circle using the trapezoidal rule. So when we work that out, we get 12.3. Finally, we want to check it with the analytic one. So we know that circle area is equal to pi r squared. We know that so that's 3.14 times 9, because the radius is equal to 3. So we multiply that out and we get 28.2 or so, something like that. So then you go, what happened there? Because the trapezoidal rule gave me an answer of 12. Well, actually I made a mistake there. The trapezoidal rule gave me 24.6. Because remember, I was only looking at the top half of the circle when I applied the formula. So the trapezoidal rule applied to the circle gave me an area of 24.6. Because again, it's an approximate, it's a numerical method. I would expect that if I broke it into maybe 10 intervals or 20, then it would get more and more accurate. It would get closer and closer to the exact answer. So that just gets that idea across, that remember, the trapezoidal rule is an approximation. As far as the trapezoidal rule was concerned, it saw, okay, you've got these heights, h1, h2, h3, h4, and it just assumes the area that it's giving you is for something where you just have a straight line between them, which is not exactly a circle. So it will not exactly match the correct answer. So that was my mistake. I kind of thought, oh, what happened if you do that? I was kind of curious to see how accurate it would be, but it's unnecessarily complex. The fact that, you know, it assumed you need to know the circle to be able to work out h1, h2, h3, h4, and h5, and you need to remember that you have to multiply by 2, that you can only apply that method to work out the circle if the area is completely full. So anyway, at least we've gone through that, and you can see it's the same formula, you know. So yes, it's a bit messy, but it's not complicated. Though in this case it was unnecessarily complicated. So finally, we just have the example of the function. So in question 3, we have the function x squared plus 2x plus 1 from 0 to 4. So again, you know, we can just plot our axes. It's going to end up at 4. It'll start at 0, so I'll break it into 4 intervals. So from 0 to 1, 1 to 2, 2 to 3, 3 to 4. Fortunately, the width is 4, so that means the area we're looking at has width 4. We're breaking it into 4 intervals, so the width for each interval is 1. So it's just a normal function. So when x is equal to 0, we get x squared plus 2x plus 1 is equal to 1. When x is equal to 1, we get x squared plus 2x plus 1 is equal to 4. When x is 2, we get 4 plus we get 9, and so on. So we get a curve. This is a bad drawing. It'll be more like that. The fact it's an x squared type function. So we'll write that out in a table that makes more sense, and then we're done. So x1 is equal to 0. x3 is equal to 2. I suppose it would make more sense to call them x0 is equal to 0, but same difference. So h1 is equal to 0. So each one of these are going to equal x squared plus 2x plus 1. So h2 is 1 squared plus 2 plus 1, which is equal to 4. h3 is equal to 9 plus 6 plus 1, which is equal to 16. h4 is equal to 16 plus 8 plus 1, which is equal to 25. Check that again. X equal to 2 here. See, I got confused by my own notation there. So h2 means x equal to 1. So here x equal to 2, so it's 4 plus 4 plus 1. For h4, well, I'll just call that h5 because they've already worked it out. h4 means x equal to 3, so that's 9 plus 6 plus 1, which is equal to 16. Okay, so now just plug this into the trapezoidal rule formula, since we have all the information we need. So width, which is 1, over 2. So h1 is equal to 1. So actually that's wrong, because when x is equal to 0, x squared plus 2x plus 1 is equal to 1. So that's gonna h1 plus h5, like the two endpoints, plus twice the sum of the other ones. So 4 plus 9 plus 16. Okay. So now we just add those up. So these two is add up to 26, plus 2 times 29. So that's a half times 26 plus 58. Which is 88 over 2, or 44. Let's check that again. 20 plus 58 is 78, plus 6 is 84. So that's wrong there. 84 divided by 2 is 42. Now, we don't have a formula for this one, It's not a circle or whatever. Though, using integration, you can work out what the area is, and it's, I think, 41.3. So the exact answer. So where's the? Yeah. So which is pretty close to 42. Again, if you want it more accurate, you break it into more intervals. And the main power is that with the trapezoidal rule, you have a method that lets you work with whatever shape you're working with. So it's far less. You're not restricted to just circles and triangles. This was a tricky set of things to look at. So you're not expected to be able to do this kind of stuff. Particularly, say, at the circle, this function, that kind of thing, you might be asked. And in fact, the past paper solution that we looked at on Wednesday was along those lines. So question 2, the circle, was a bit on the hard side. Remember to subscribe to be updated when new content is added. Thanks.